Welcome to the Advantech Technical Training. In this topic we will talk about Common Industrial Protocol. Outline: these are the agendas about this session. First of all, what is protocol is the most important topic to understand. Secondly, common protocols and protocol gateway are represented in this chapter. Third, we are going to tell more details about Modbus protocol including format, function code, exception code, and mapping table. Fourth, another kind of protocol is usually used in IoT will also be introduced in this chapter. Final, we show some steps in order to test ASCII Modbus MQTT protocols and their own third-party software which can be found in the internet. What is protocol? When people talk with each other, we use language. This concept, language, is generated by a human being to transfer knowledge or experience from one person to the other. Some people use Chinese, Japanese, English, French, Spanish, etc. However, machine also needs to talk with each other in order to transfer data. The word protocol is used instead of language to describe when machines are communicating. Human use some interfaces like cell phone, walkie-talkie to talk. Compare to interfaces for language, RJ45, RS-232/422/485, etc. are interfaces and also generally used in industrial field. Common protocols. Please check http link to check common protocols which are widely used in industrial field. We will show you some common protocols and who developed them. ASCII is a common protocol which is a character-based encoding standard for electronic communication and also widely used in certain devices. ASCII was released in 1967 for first edition and the latest update in 1986. It defines 128 characters including space key in keyboard. You need ASCII table in the slide shown above to decode binary to real physical meaning. For example, the enter in keyboard is 0D in hexadecimal number, 1101 in binary number. Profibus, process field bus, is a standard for field bus communication in automation technology and was first promoted in 1989 by BMBF, German Department of Education and Research, and then used by Siemens. Profibus DP, decentralized peripheral, is used to operate sensors and actuators via a centralized controller in production, factory, automation applications. The many standard diagnostic options, in particular, are focused on here. Profibus PA, process automation is used to monitor measuring equipment via a process control system in process automation applications. This variant is designed for use in explosion/hazardous areas. The physical layer conforms to IEC 61158-2, which allows power to be delivered over the bus to field instruments, while limiting current flows so that explosive conditions are not created, even if a malfunction occurs. The number of devices attached to a PA segment is limited by this feature. PA has a data transmission rate of 31.25 kbit per second. Profinet, process field net, is an industry technical standard for data communication over industrial Ethernet, designed for collecting data from, and controlling equipment in industrial systems, with a particular strength in delivering data under tight time constraints. In order to achieve what definition from above? TCP/IP for non-time critical data and the commissioning of a plant with reaction times in the range of 100 millisecond. RT, real-time, protocol for Profinet applications with up to 10 millisecond cycle times. IRT, isochronous real-time, for Profinet applications in drive systems with cycles times of less than 1 millisecond. Ethernet/IP is an industrial network protocol that adapts the common industrial protocol to standard Ethernet. Ethernet/IP is one of the leading industrial protocols in the United States and is widely used in a range of industries including factory, hybrid, and process. The Ethernet/IP and CIP technologies are managed by ODVA, Inc., a global trade and standards development organization founded in 1995 with over 300 corporate members. Rockwell Automation, Allen Bradley, and Omron are representative of Ethernet IP. BACnet is a communications protocol for building automation and control networks that leverage the OSHRI, ANSI, and ISO 16484-5 standard protocol. BACnet was designed to allow communication of building automation and control systems for applications such as heating, ventilating, and air conditioning control, lighting control, access control, and fire detection systems and their associated equipment. The BACnet protocol provides mechanisms for computerized building automation devices to exchange information, regardless of the particular building service they perform. BACnet contains serial RS485MS/TP and Ethernet communication BACnet/IP. EtherCAT is an Ethernet-based field E-bus system, invented by Beckhoff Automation. Short cycle times can be achieved since the host microprocessors in the slave devices are not involved in the processing of the Ethernet packets to transfer the process images. All process data communication is handled in the slave controller hardware. Combined with the functional principle, this makes EtherCAT a high-performance distributed I/O system. Process data exchange with 1000 distributed digital I/O takes about 30 microsecond, which is typical for a transfer of 125 byte over 100 bit/s Ethernet. Data for and from 100 servo axis can be updated with up to 10 kHz. Once languages between two machines are not the same, in this case we need to translator to help machines can communicate with each other. Protocol gateway, or we call them protocol converter, is the device to help us translate one protocol to the other. Not only protocol, but also convert hardware interface from one to the other. You do not need to know how to do programming to the protocol that you are not familiar with, using protocol gateway to reduce the time when you develop application in computer. In few decades ago, if you want to exchange data between two protocols, you need lots of time to investigate two protocols including format, data type, human error, etc. As long as you have protocol gateway, you do not have to know detail of protocols but only need few parameters to communicate with each other. Therefore, Advantech has several types of protocol gateway to help customer convert protocols such as Ethernet/IP, Profinet/Profibus, BACnet, EtherCAT to Modbus. Please refer the picture as above to see worldwide market share and their manufacturers. Modbus protocol. Modbus is created by Modicon in 1979, which is also used by different vendor controller in worldwide. It is very easy to understand when you follow the principle of Modbus. It is designed for industrial applications and openly published without any copyright fee. In addition, the difficulty of deployment and maintenance of Modbus is relatively lower than any other protocol. For these industrial protocols, the basic action is that master generate a request command and send it to slave device through interfaces. If request command is totally correct, slave would respond the status at that moment back to master. Master would follow principle of protocol to decode binary number in order to get data. This is the comparison table between Modbus RTU and TCP. It is obvious that Modbus RTU has CRC to check command, but Modbus TCP does not have. More information will be introduced in the next few slides. Modbus TCP also needs to follow TCP standard. Before Modbus command, client has to start TCP connection and then server will acknowledge this connection. Afterwards client and server would start common Modbus actions until client wants to close this connection. This slide is to show detail query command of Modbus TCP, which combines command head and body. Command head has 0 in 11 times and a 6. Then command body is also the same with Modbus RTU but without CRC parameter. This slide is to show detail response command of Modbus TCP, which also combines command head and body. This table is to describe function code, their name, and utilization of Modbus for RTU and TCP. Beware of that the code is in hexadecimal number. Sometimes programmer would misunderstand this as decimal number. This slide represents that if devices receives false request message, it would reply a command with exception code which indicate what kind of error is between communication. We also list a exception code table below to indicate every situation. In Modbus RTU communication, you need CRC in the end of request command. However, it is very complicated for human calculation. Fortunately nowadays we have online resource to help us calculate CRC to enhance efficiency when you do programming. General speaking, RD can define where to put their data and read/write capability by themselves. When you receive a Modbus device you also need to ask for Modbus mapping table which helps you know where data is. Function code 3 and 4 contains word data, which is usually used to represent analog value. Function code 1 and 2 contains bit data to indicate digital status. Industrial and IoT protocols. For the polling and response action, it is designed for industrial generation because we need to know data value in every second or even in millisecond. There is always a master and slave which send request and response command between. In IoT generation, data or information would be provided to lots of people. This method is not convenient and efficient in IoT 4.0. Publisher does not need to know who would like to know the message, only needs to send message to broker. It knows who would like to know the message. Once messages have been received or updated, broker will send message to subscribers. They do not need to send request command, only need to wait for messages updated. JSON format which contains string of data are commonly used in messages. MQTT, Message Queuing Telemetry Transport, is an ISO standard publish-subscribe based messaging protocol. It works on top of the CPIP suite. It is designed for connections with remote locations where a small code footprint is required or the network bandwidth is limited. The publish-subscribe messaging pattern requires a message broker. Message type. Connect, waits for a connection to be established with the server and creates a link between the nodes. Disconnect, waits for the MQTT client to finish any work it must do, and for the CPIP session to disconnect. Publish returns immediately to the application thread after passing the request to the MQTT client. Each connection to the broker can specify a quality of service measure. These are classified in increasing order of overhead. At most once, the message is sent only once and the client and broker take no additional steps to acknowledge delivery, fire and forget. At least once, the message is retried by the sender multiple times until acknowledgement is received, acknowledged delivery. Exactly once, the sender and receiver engage in a two-level handshake to ensure only one copy of the message is received, assured delivery. This slide is to show advantages of IoT protocol. General speaking, due to data size should be as small and precise as possible, messages do not contain useless data in package. Easy to send, easy to get. There are lots of popular web services around the world which implement MQTT protocol. For example, Facebook, Amazon, Microsoft, Node-RED, Raspberry, and Advantech, etc. How to test ASCII, Modbus, and MQTT. We provide some common protocols testing tool listed as above. We will also provide quick SOP in the following slides about how to test ASCII, Modbus, and MQTT. In ASCII command we need to know how to put command. For example, our command is number 02 with carriage return. In ASCII table, number is 23, 0 is 30, 2 is 32 and carriage return is 0D in hexadecimal number. Command number 02, CR, is 2330320D to be put in the command line. You will see response in above column. In Monitor tab you can also find raw data of ASCII command and response if command is correct. Otherwise no response would show up in access port. In Modbus protocol, you can use ModScan to check raw data in ModScan. First of all, you have to put correct IP/port or COM port parameters including baud rate, data bits, parity, and stop bit to make communication work. If communication establishes successfully, you still have to put correct device ID, function code, address and length to generate correct request command. If all parameters are correct, you can see raw value in the bottom column. You can also check data flow in traffic mode. No response, response with exception code or correct response, they all have different data flow. You need to have lots of experience and knowledge to read raw information of Modbus. Modbus Poll is another software to get Modbus data. It is almost the same as ModScan including user interface. Unfortunately it does not have free trial version to test Modbus device. In order to test MQTT, we need third-party broker software from HiveMQ and MQTT client from Payo. Please follow steps in the next few slides to build up MQTT environment. First of all, download HiveMQ broker from the link above. The free trial version has some limitation, EXMAX connection only to 25 links. After fill in your information, you may get a download link such as https://www.hivemq.com/download.php, token equals C81BD8E43981F7BCF7FE33CDA4Fa58. Second, follow the readme.txt. Right-click on bin/run.bat. The broker on the PC would start to listen connection. Default setting, no username, no password, port 1883. These are quite important due to they must be filled in MQTT publisher and client. Please pick up one of MQTT client software to install in your computer. Put broker's IP and port in MQTT client software. If there is no error, status would show connected. Then subscribe broker and wait for the results are pushed by broker. Thanks for your attention. Wish this document gave you basic concept about common industrial protocol.